Okay, please, you're most welcome. Make sure you subscribe to the channel. All right. Now we are in for lesson 7. Lesson 7, still about lines. And now we are on a subheading, shortest or perpendicular distance from a point to a line. From a point to a line. All right, now, what you call perpendicular distance? What you call perpendicular? This word perpendicular, I told you, it means at right angles. If they use the word at right angles, they use the word at right angles. They use the word normal. Normal to the line, like that. They all mean the word perpendicular. Or at 90 degrees. That's what the word perpendicular means. Now, in simple terms, to find the shortest or perpendicular distance from a point to a line. Now here we shall imagine. Remember that our equation of a line is always like this. R is equal to a vector plus lambda mu, whereby lambda mu is a parallel vector. How do you get a parallel vector? By subtracting. All right. So, we shall assume that, okay, what if we have our line like this? Our line in that order. And this is a line, say R is equal to vector A plus lambda mu. But now we know that this A, of course, I told you that OA vector is the same as that A. Please, must bear that in mind. So, why is small a be seeing the capital A? Now, this A is always a point on a line. So, if this is our line, I'll come and put this point on a line. The point on the line which is now A, like that. The point on a line which is A. This is our line R is equal to lambda A, rather vector A plus lambda mu. Now, like that. So, after doing that, now they are saying a perpendicular distance from a point to a line. Now, this is our line. Now, we need a perpendicular distance from a certain point. Now, what if we put a certain point this side? This is now our point, say for example, B. Now, what a perpendicular distance of that point? Perpendicular means making an angle of 90 between the point and the line. So it means that here, if we bring a line also downwards to connect it with this is what we call the 90 degrees. We must see that the 90 degrees obeyed. Perpendicular. So this point is perpendicular. You drop a perpendicular from the point up to there. And that is at 90. Now, the distance we want B is this one. From here up to there, that's the distance we want. But of course, bearing in mind that from here, we know that, okay, since it's vectors, we can join this. We can join this, okay, to that. Now, how do we get the perpendicular distance? How do we get the perpendicular distance? Perpendicular distance is got from, say, D. Your distance D is equal to a magnitude of AB vector, you cross it with mu, over magnitude of mu. Yes, you all know mu. Mu is a parallel vector, which is got by subtraction, and the mu is got from the line. And now as simple as that. But if you want to sketch, this is how it goes. The line, then you put a point up, then you draw a line, draw a perpendicular from the point to the line. Should be make an angle of 90. All right, now let's define some of the words used there. Where mu is the parallel vector. Now, where is that mu? We say that mu we get it from the denominators of the line. Mu we get from the denominators of the line. Then A is a point on a line. Point on a line. Point on a line, if a line is in the Cartesian form, what I'm meaning, if a line is in this format, to get mu, denominators. To get the point on a line which is A, numerators. And what I'm meaning, equate this to 0, you get the value of x. Equate this to 0, you get the value of y. Equate this to 0, you get the value of z. Lastly, B is a point whose distance from a point is required. Now, B is the point which is far away from the point whose perpendicular distance is required. And then the formula we use is D is equal to magnitude AB cross mu. All right, good. Now we have an example here. This can be set in UNEB and even in mock bodies. So they're saying find the perpendicular distance from a point B to a line. All right, so from point B to a line, that, very good. So what I'm going to do, I will say solution. If you want, you can sketch. You begin with the line, please. You begin with the line like that. So knowing that here, you need your point A. You put that the coordinates, okay, like this. Now this is your line R is equal to, now I want to change it to what you all understand, plus lambda, that, okay. Now, what shall we put here? The denominators there, so -1. Oh, sorry. Equal equals to 0, it will be 1. Y will be 2. This will be 3. Please, where I'm getting this from is equate this to 0, x will be equal to 1, equate this to 0, y will be equal to 2, equate this to 0, z will be equal to 3. That's what I'm having there. Now the lambda, which is lambda mu, the mu here get from the denominator. Denominator is 3, this is negative 1, and this is 2. Please, I've changed it, but you can as well go direct. All right, good. So, but now the point A which we want is this one here. So, which is 1, 2, and 3. Now, the perpendicular distance, meaning that the point B is this side. This is our point B, which is a 4, negative 3, and a 0. So, point B is there. So, you drop a perpendicular from there up there. And should be making an angle of 90. Maybe you can come and complete up this triangle, but the distance required is that. Okay. Now, the distance is got from, so now I shall say from D is equal to magnitude AB cross mu over magnitude of mu, like that. Now what you're going to do, we need to get this AB cross that. So now let's first of all get AB. We all know that AB, these are vectors. AB is equal to, a position vector AB is equal to OB minus OA, like that. So what are we going to have finally? What are we going to have? So OB is 4, negative 3 is 0. OA is 1, 2, 3. Which answer are we going to have here finally? Which answer are we going to have here? So when you subtract 4 minus 1, you get a 3. A negative 3 minus 2, you get a negative 5. A 0 minus 3, you get a negative 3. So AB will be that. AB will be that. All right. Now I'm begging to proceed. Let us proceed. Let us proceed with our work. Okay, well, I can even use that small space which is remaining there to see the way forward. Now, this one will be, allow me to use this space here. So you realize that now magnitude, now, we need to cross. Now, AB cross mu. So AB cross mu. AB cross mu. Yep. Now it will be our mu. What will be our mu? AB cross mu. By the way, here, I told that this one becomes your mu. This one becomes your point A. This is your mu. So this is your mu here. Now, I'll bring and say this one is 3, negative 5, and negative 3. We are crossing it with 3, negative 1, 2. We are crossing them. AB cross, okay, mu. And now we say that in the crossing, please, you're always advised to have a piece of paper so that you can do the covering. And I have one here, which you're going to use. So you do the covering, you see how the answer will come about. So I'll write my answers here after crossing. My answers will be here. Now we come and cover. When you cover up, you see that you remain with the 2 by 2 matrix. Negative 5, negative 3, negative 1, 2. So to get major diagonal, I will say negative 5 times 2. That will be negative 10 minus the minus which is there. Then negative 3 times 3 will be negative 3 times negative 1 will be 3. Done with that. Okay, finished. Now I'm going to the next level. You only get the determinant. You get their determinant. So I have 3, 3, 2, negative 3. So 2 times 3 will be 6. But I told that at this second level here, you must attach a negative by default. The negative must be there. I explained that in the lesson 2. If you didn't watch it, go and watch it, please. So that this one will be, okay, 2 times 3 will be 6 minus negative 3 times 3 will be negative 9. Finished. Now I come and cover up down. Then I remain with the 3, negative 3, 3, 3. Please, what I'm meaning is, once you have 3, negative 5, then you have 3, negative 1. Please, you all remember from all level how you get determinant of a matrix. Is what I'm doing. So, after doing this, major diagonal is negative 1 times 3, will be negative 3, minus, okay, negative 5 times 3, will be a negative 15. That's now my major diagonal after crossing. So now this will be, I'll now conclusively say that AB vector cross mu will give us a certain vector here. Subtract, you shall get negative 13, then you shall get negative 15, Then here also we shall get, okay, we shall get a 12, if you can really see that. Let's now proceed and conclude. It is a very examinable question, especially in section A, 5 marks. All right, good. So let's proceed. Let us proceed. But remember, as per the formula, we need the magnitude of this. So therefore, we shall now say that magnitude of AB cross mu. The magnitude of AB cross mu is just equal to the square root of, you bring that, negative 13 squared plus negative 15 squared plus, all right, 12 but squared. Which answer are we going to have there? You get your calculator and we see how that can be done. Use your calculator. So that is negative 13 squared plus negative 15 squared plus 12 squared. The answer is 538. 538. As simple as that. The next, okay, as per the formula, we have obeyed this one, like we are. Then we need to also obey this one. So magnitude of mu, remember, your mu is originally equal to, I told you that mu is this one here. 3, negative 1, okay, 2. So now magnitude of mu will be equal to a square root of 3 squared plus negative 1 squared plus 2 but squared. So this will now give us a square root of this is 9 plus this is 10, 14. That will be 14. Now we come and say, from your formula, the perpendicular distance D is equal to magnitude AB when you cross it with the mu over magnitude of mu. So now your D will be equal to, all right, this whole thing is here as root 538 divided by this one is here 14, a root 14. So our D will be equal to, all right, square root of k divided by square root of 14. The answer we have is 6.1991 units. So now that is our perpendicular distance. Our next subtopic is planes, the mighty planes. Not a topic but a subtopic, still under vectors. We're going to look at planes.